show by the principle of mathematical induction that for all n belonging to the set of natural numbers, we have here an equation, the sum of the first n odd natural numbers equals n squared. So let us begin. First, what we'll do, we're going to consider a statement and call it P of n. P of n. P of n such that 1 plus 3 plus 5 going all the way up to the nth term, which is 2n minus 1, that's the sum equals n squared. So we're going to name this as statement number 1. Now we'll consider the first natural number, which is 1. So for n equals to 1, what we get is P of 1. So that's going to give us only the first term, because we are considering n to be equals to 1, that equals 1 squared. Now clearly we know the 1 equals to 1 squared. 1 equals to 1 squared means 1 equals to 1, which means that the statement P of n is true. P of n is true for n equals to 1. If we choose the first natural number 1, then the statement P of n is true. Now we'll have to verify that the other natural numbers also makes it true. To show that it is indeed true, we're going to consider another statement P of m. So here we're saying that let P of m be true. So if P of m is true, this means that we can now rewrite the statement as P of m such that we have 1 plus 3 plus 5 going all the way up to 2 times m minus 1. So here we are considering the first m odd natural numbers, that's equals to, the sum equals m squared. We're going to label this as number 2. Okay, now using this statement, we need to show that if P of m is true, we need to show that P of m plus 1 is also true. That means the next consecutive odd natural number also makes the statement true. So how do we show that this is indeed true? So what we'll do, we'll have to show that P of m plus 1 will such that we have 1 plus 3 plus 5 going all the way up to 2 times m minus 1. We'll also have to consider the next term. So we'll have to replace the m with m plus 1 to get the next term. That's going to give us 2 times m plus 1. This is going to be equals to m plus 1 whole squared. So we need to show that this is a true case. So how do we do that? Well, we'll start from left hand side. So on the left hand side, we have 1 plus 3 plus 5 going all the way up to 2m minus 1. And to it, we are adding one more term, which is 2m plus 1. Now, if we take the first m terms, and this is simply going to be m squared as given in number 2, because we have already stated that P of m is a true statement. So we're going to replace this with m squared. So we have m squared plus 2m plus 1. Now what is m squared plus 2m plus 1? So if we complete the square, what we get is m plus 1 whole squared. And this is exactly the expression on the right hand side, m plus 1 whole squared, which means we have shown that this implies that left hand side equals to right hand side, or in other terms we can say that the statement P of m plus 1 is true. So since P of m plus 1 we have successfully showed that it is true, therefore we can generalize now and we can say, hence the statement, original statement P of n is going to be a true statement for all values of n belonging to the set of natural numbers n. So this we have proved using the principle of mathematical induction.